Scholastic Home Video Tutor. Integration by substitution. Example 1. Using a suitable substitution, evaluate integration of dx divided by x plus 1 times root of x plus 2, limits from 7 to 14. And here if you look, we can substitute root x plus 2 with a substitution u. So therefore u squared equal to x plus 2. So differentiate with respect to x, we get 2u du over dx equal to x will become 1, 2 becomes 0. So therefore 2u du equal to dx. Since u squared equal to x plus 2, we can write x equal to u squared minus 2, take to the other side, and x plus 1 equal to u squared minus 2 plus 1 equal to u squared minus 1. We will require this one later on for substitution. Now let's look at the limits. When x equal to 7, u was actually substituted with x plus 2 root, and therefore u is equal to x equal to 7 here, 7 plus 2 root of 9 equal to 3. Also when the upper limit of x equal to 14, u equal to 14 plus 2 root 16 actually is equal to 4. That's the upper limit for u. So therefore lower limit for x equal to 7 to 14, upper limit will become 3 to 4 for u. And other substitutions, x plus 1 equal to u squared minus 1, root of x plus 2 equal to u, dx was equal to 2u du. So we get these substitutions, and then we get this one after simplification. And now we have a term here which is not possible to integrate as it is, 1 over u squared minus 1. So now what we are going to do is we are going to apply a thing called partial fractions. So partial fractions will separate it into two fractions, 1 over u minus 1 into u plus 1, which can be written as a over u minus 1 plus b over u plus 1. So we can make the denominator term equal by multiplying by u plus 1 and u plus 1. And here you multiply by u minus 1 and u minus 1. So the denominator term is equal. Therefore numerator term is 1 equal to a u plus 1 plus b into u minus 1. So that's what we get here, 1 equal to a u plus 1 plus b u minus 1. And the terms, the coefficients of u is equal to a plus b, and the constant terms are a and minus b. And now we equate the coefficients of u and constant terms in the left hand side and right hand side. So u times a plus b in the constant is the coefficient of u. There is no u term here, therefore a plus b equal to 0, and a minus b is a constant term here, and the constant term here is 1, therefore 1 should be equal to a minus b. And now we can substitute second equation in the first equation to find out the value of b. From second equation we can see a equal to 1 plus b, so substitute it here. We get 1 plus b equals 0, means b equal to negative half. And also we know a equal to minus b from this equation, therefore a should be equal to negative of negative half, means positive half. Now we come to the original equation, I equal to integration 3 to the 4 2 du over u squared minus 1, and now substitute the result that we got just now that the partial fraction of 1 over u squared minus 1 equal to a over u minus 1. A was half plus b over u plus 1. B was negative half. And after simplification, you can see this form here, 1 over u minus 1 du plus 1 over u plus 1 du here. Actually, this is another formula here, where if you have a formula like that, fx, derivative of fx is f dash x. If it is in the numerator, then the function will become ln, natural logarithm of fx, and the limits are from a to b. Here we have fx u minus 1, therefore f dash x equal to 1. So which is equal to this formula here. So therefore we can apply this formula here. 2 term to 1, integration 3 to 4 will become ln u minus 1 from 3 to 4 minus 2 times half is 1 again, and this one again, when you differentiate u plus 1 with respect to u, you get 1 here, which is the numerator term here. Therefore you can apply this formula again here, which is ln fx. ln fx is u plus 1, limits from 3 to 4. And now we substitute the limits in the equation. Ln u minus 1, 4 equal to u ln 4 minus 1 minus ln 3 minus 1. And the second term minus ln u plus 1. So 4 plus 1 minus ln 3 plus 1. After further substitution here, simplification here, ln 3 minus ln 2, and negative means 1 over ln. So you get inside here ln 3 divided by 2 minus ln 4 divided by 4 plus 1, 5 divided by 4. And there's another negative term here, therefore this term is the numerator, this term will be the denominator. So ln 3 over 2 divided by 5 over 4. And then further simplification we will lead to the final answer, which is ln 6 over 5. That's the final answer for this question. End of the solution.